So today we're going to talk about Day 9, 8.3 initial value. Today's learning goal, I can determine the rate of change and initial value of a linear function. A linear function can be written in the form y equals mx plus b. You can see both the rate of change and the initial value of the function in the equation. So we've talked about initial value. However, we always call it the y-intercept. So it's simply where the graph crosses the y-axis. And we know our m value to be our slope. You probably want to write these vocab words in your Cornell notes. So in the graph here, you can see both the rate of change and the initial value of the function in the graph. So our rate of change is simply our rise over run. The initial value is our value that crosses the y-axis. So our goal is to match each linear function with this initial value. Again, remember that our equation is y equals mx plus b. Our initial value simply means our b value. That's what we're ultimately looking for. So let's go ahead and identify what exactly are our b values in each equation. 3 is the first one, positive 2 is the second one, positive 3 is the third one, and negative 2 is the last one. Notice how the b values are not attached to x. So if I want to match each one with the value that it goes with, the first one would match up with the last portion here. So I'm just going to draw an arrow here. The second one here would match up with positive 2, so it would go to the green. The third one is positive 3 as our initial value, so it would match here. And the last one, our initial value is negative 2, so it would match here. So which linear functions have an initial value of negative 4? So again, the great thing about it is that we're looking for negative 4. If we go through 1, 2, and 3 and identify our initial values, it would be great. So our first initial value is positive 5. The second initial value is negative 4. It's the only one that's not with the x. And the third initial value is positive 5. So based on the initial value that we're looking for of negative 4, only 2 would be our answer. The graph represents the function described in words below. Write each value or equation for the linear function. Josie has 1.5 cups of water in her watering can. She fills the can before watering her plants. Water flows into the watering can at a rate of 1 cup every 4 seconds. Well, here we're asked to list out the rate of change of the function, the slope of the line, the y-intercept of the line, and the initial value of the function, and then create a function rule. So if we look here at the first set, the rate of change of the function is the same thing as our slope. So we can simply do some math that deals with rise over run. So we're going to go ahead and pick some points that cross the grid. So there's a point here. There's also a point here. Well, let's do our rise over run. So we rise up 2 units, and our run is going to be over 2, 4, 6, 8 units. So when writing out our fraction for rise over run, we would get rise being 2 over our run is 8. Well, 2 over 8 reduces to 1 over 4. That is going to be my rate of change. Also, it's going to be the slope of the line. The second thing we're looking for is our y-intercept of the line and the initial value. Well, these two things mean exactly the same thing. They want to know, where does our graph cross the y-axis? Well, it crosses the y-axis right at this point. And at this point, we cross the y-axis at 1.5. So that is going to be our initial value / y-intercept. Well, now we need to create a rule for this. Remember, the equation is y equals mx plus b. We identified our m value to be 1 over 4, and our b value we identified as 1.5. Well, if we set it up as a rule, I'll put it in blue, y equals our m value, which is 1/4 x, plus our b value, which is 1.5. What is the rate of change and the initial value for the function in the graph? So they ultimately want us to find the slope and y-intercept. So think about your equation, y equals mx plus b. We want to know what m is, and we want to know what b is. Remember, m can be found by doing rise over run when you have a graph. So again, pick 2 points that cross the grid. And there's 2. So from this point here going down, we count up each unit is by 2. So from 6 to 4, we went down 2. As we go to the right, we go over 1 unit. So my rise over run effect is going to be -2 over 1, which is simply -2. Well, remember, the b value is simply where our graph crosses the y-axis. Where it crosses the y-axis is at 8. So there's my initial value and my rate of change. The linear function in the graph models the height off the ground in feet of a person riding a zip line t seconds after pushing off from the platform. How high off the ground is the platform? Well, let's identify what we're talking about here. It says the linear function is the graph modeling the height. So if we have the height off the ground is in feet, we know that h represents our height. Then it tells us that t is in seconds after pushing off from the platform. So we know t represents our time. The question they want us to answer is how high off the ground is the platform? So they want to know what is our exact height. So we're looking for our h value. So looking for h. So we can solve h by letting t equal 0. If we do that, we get h equals -5 over 4. We're going to let t equal 0 plus 100. So if we solve this out, we know that -5 over 4 times 0 is just 0. So h is going to equal 100. Our label is going to be our height, which is in feet. So 100 feet is how far off the ground the platform is for the zip line. Last question. The function d equals 125 plus 80n models the amount of money in dollars the zip line ticket cashier has in her cash register after selling in tickets. How much money did the cashier have in the register before she sold any tickets? Well, let's identify what we know. So we know that N represents the amount of tickets that we're selling, and D is going to represent the amount of money in dollars. So let me change my color there. D is going to represent the amount of money in dollars. So they want us to find out how much money did the cashier have before she sold any of those tickets. So in our case, we're going to be looking for letting N equal 0, because we want to know exactly how many tickets, we want to know how much money did she have before she even sold one ticket. So in our case, our equation says D equals 125 plus 80 times our N value, which we're going to let equal 0, simply means that D equals 125 and 80 times 0 is just 0. So that means that she started with $125 in the register before she sold any tickets. If you guys have any questions, that's it for the lesson. Please write them down and we'll do some problems tomorrow. See you guys.